Question number 13 on page 121. It gives you some sculpture here. It gives you some dimensions of the sculpture. And it asks us to find the maximum width of the moon dog. So the maximum width that we're going to find is basically going to be this horizontal line length right there. And to find that horizontal line, what we're just going to do is, first of all, we're just going to split it into two because that is symmetrical. It's the same on one side as the other. And then we're going to solve for different parts of this. So we need to find essentially this length. I'm just going to highlight the two lengths. We need to find this length here, and we also need to find this length here. And once we double those lengths, we can get the total distance across. Okay, so the first thing we're going to do is find the length, that red length in here. We're just going to call that x. And I'm going to use the sine law to set this up because I do have side and opposite angle pairings in the bottom triangle. And I'll just highlight that in purple here. This triangle here, we're going to use the sine law. So I'm going to set up my pairing. I'm just going to do that work down here. I'm going to have x compared to the opposite angle, sine of 33.5 degrees. And that's equivalent to a known pair in that triangle. And we'll use this angle here and this side here. So we get 161.3. And that's all over sine of 73.25 degrees. Okay, and then solving for x, length of x, we end up with a length of 92.97, and that's in centimeters, and we've used the sine law to get that length there. So that is that yellow highlighted length. So we're going to need to find the blue length. And to do that, we need to solve this right triangle. Okay, and I'm just going to highlight this right triangle. But the problem with this right triangle here, that green right triangle that I've just highlighted, is that we don't know any of the sides or angles. So we're going to have to, first of all, find an angle in there. So I'm going to find the angle in there by using the triangle above it. So I'm going to make sure that the triangle, again, I'll highlight this in different color here. This blue triangle, I'm just going to find the angle in the corner. So adding those two angles, 73 plus 29, and subtracting that from 180 degrees, I get 78 degrees in that corner. And that gives us 42 degrees here because we know that those three angles add up to 180 degrees. So I've got now an angle in the green triangle. Now I need to figure out one of the side lengths in the green triangle. And I'm going to do that by using the length x that I've already solved for. So that length is going to be the 92.97. And I have an opposite angle pair. And I'm going to use the angle and opposite side pair here, and that will give me a length of y, which then will give me a side length in that green triangle. So that's my next step. I'm going to set up a ratio for y. So y over sine 73 degrees. Okay, so that's an opposite angle pairing, and I'm going to equate that to one of the known opposite angle pairs here. So the x value, which is 92.97, over the opposite angle, which is sine of 29 degrees. So now I can apply sine law here and solve for that unknown side of y. And so solving for y, the y value works out to be 183.39 centimeters. Okay, so now that's giving me a side length. I'm just going to write that in. 183 0.39. Okay, well, that's kind of a bit messy, but that length in here, 183.39. Okay, so then I've now got a side and an angle in that green triangle. So I'm going to solve for that blue side here, which I'm going to call, let's give that call that Z. And that Z then will allow me to get halfway across this diagram. So using that green triangle, and maybe I'll just draw it out here. That green triangle now looks like this. I've got a 42-degree angle. I'm finding the horizontal line, and that's a horizontal line that goes all the way across the sculpture. I have a length here of 183.39 centimeters, and I found that using the sine law in that blue triangle. And now I can just use trig to find this side length, Z. So that's my adjacent side. So I'm just going to do cosine of 42 degrees, and that's equal to the adjacent side Z, which I'm looking for, over 183.39 degrees, or sorry, 183.39 centimeters. And then solving for Z, I get a Z length that works out to be, when I solve this equation, 136.29 centimeters. Okay, and that represents that blue highlighted length. I now have the two lengths I need to calculate half the distance. So the total distance, so this would be the total width, would then be equal to double the red length, which is 92.97 centimeters, plus the 136.29 centimeters, and I multiply that by 2, I get 450, looks like it's 458.52 centimeters. Okay, and then that gives us the total distance across from point to point. So this, from point to point, it's 458.52 centimeters.